So we're going to get started in just a little bit, but we're going to do some announcement first. But while we're getting set up, those of you who have Unity should go ahead and open up a new Unity project because it takes a little bit to boot up. So in order to do that, first you click on the shortcut or open up wherever you stored Unity. Usually it's just a shortcut, or go to the Windows menu. You should see a screen that looks something like this. You want to click on this new button up here. And depending on what version of Unity, it may look a little bit different, but I'm pretty sure everybody should have a screen that looks similar to this. Yeah. So you name your project, save it wherever you want to save it. But what's important is you have this drop down here called templates. Make sure you hit 2D. That's just, we're going to be making a 2D game here. If you accidentally hit 3D, there are ways to get it back to 2D, but it's a little bit convoluted, and it's better to start off on the right foot. And so, yeah.
At any time, just raise your hand, and we'll have someone come over and deal with any mishaps that are going on.
Yeah, we have lots of people here who have experience, especially officers. And we have officers who will be walking around to help you if you get stuck or have any questions or any mishaps that might happen. Yeah. That's not spoilers. All right, so you guys good to go? Okay, so let's go ahead and get started. Hello, everyone. Welcome to another week of Game Dev Club. So, as promised today, we're going to be doing our quarterly Unity beginner tutorial. So, for those of you who are new to Unity, this will kind of get you up to speed on how the editor works, so you can start making your own projects. For those of you who do know Unity, because I know there's a number of you here who have been with us in the past, there are a couple options for you. You feel free to follow along. Maybe you'll hear something that you don't know, or I always seem to learn something new about the editor sometimes. Or you can work on your own stuff. If you really want to be helpful, there are obviously people around you who aren't as experienced, so if they get stuck, if you could help them out, that would be awesome. Of course, like I said, we're going to be having our officers that are out and about to help out, but the more help we have, the merrier. Or if you want to be really adventurous, we're going to do, like we did last time, we're going to be doing we called it the Suck Jam last time, but I guess
the Tutorial Jam.
Again, Tutorial Jam. So if you really want to be adventurous, you can make a game in the time span of the tutorial, which lasts about an hour 15 minutes. Yeah, that's some of the options. So before I get started in the tutorial, you actually have a number of other announcements. The first thing I want to mention is the Winter Game Jam, which will be 2 weekends from now, February 1st to February 4th. For those of you who don't know what a game jam is, the idea is you want to make a game in a weekend. They're a whole lot of fun. We usually bum a room here. I usually buy pizza on Saturday because of my large dining account. We hand out a theme, and it's a great time. So I suggest everyone, like I mentioned last time, I suggest that all of you do it and just make games. On that, kind of follow that, Sam actually has an announcement real quick about Game Dev Saturdays. Do you want to?
Or Sundays.
Or Sundays.
So people have expressed interest on getting together on Saturdays or Sundays because we did that last year. So if you want to come make games, we'll do that. We haven't decided on a date or time, but Saturdays or Sundays probably. You can just come work on a project. Probably Mary Gates or EEB, whatever one. Yeah. Just pay attention to Discord and we'll talk about it.
Cool. Yeah. Keep an eye out that for Discord. It's because it's just time to make games. And then finally, she's passing out stickers right now. Emily, do you want to give an announcement about the t-shirt contest?
Oh, hi. Yes. So it's over. That's basically it. We haven't decided on the print, on the design just yet. I think we're gonna have kind of a surprise announcement when the art proof comes in, so you can see the design on the t-shirt. And also, we might be thinking of rolling out a couple other merch at the same time, so keep an eye on that. Also keep your wallet ready because they're super cool. Yeah, and that's about that. Good job everybody who submitted it to us or just generally on the general channel thing, because you guys can see I put them in a slideshow and show off all the amazing designs. I'll suck. Alright, thanks guys. I'm gonna keep handing out. Who wants a sticker, by the way?
Yeah, we have like
We'll pass them out at the end.
yeah,
Great stickers.
too many stickers.
The whole thing is
All right, so those are all our announcements. So let's hop right into the tutorial. So to go over one more time for those of you who came in a little bit late, let's open up Unity before we actually because Unity takes a little bit to open. Let's go ahead and open up a new project while I'm going to talk about some of the basics. So if you weren't here earlier, the way you do that is that you click on the Unity button. It may be the shortcuts may look like either this or this, and you should get a hub that looks akin to this screen. Click on the top right corner on New. Here you can name your project. You can choose where you want to save it, but most importantly, make sure that you set your template to 2D because we're going to be working on a 2D game here. If you accidentally send it to 3D, my suggestion is just to open up a new project and set it to 2D because it's a little bit convoluted to switch back once you get started, and it's better just to get off on the right foot. And once you have all those settings laid out, just click on Create Project, and it'll take a little bit to get set up. I already set up a project, so I won't worry about that for now. So while that's loading, let me give you a little bit of, talk a little bit about how Unity works. So yeah. Welcome to the Beginner's Guide to Unity, not 2018. These are slides I've clipped from last year, but I still like them, so I still use them. Okay, let's open up Unity. We did that already. So first off, what is Unity? Unity is a game engine, essentially a platform for making games. It is one in many platforms. Others include GameMaker and Unreal. Each have their own pros and cons, and actually most big studios make their own game engines to develop on. But the reason we start with Unity is because out of all of them, Unity is I'd say the easiest to get started with. Yeah, it's easiest to get started with. It's the most beginner friendly, and yeah, that's what most of us here develop on. And if you didn't download it, you download it there, but it'll take a while. So hopefully everybody downloaded it beforehand. Okay, so how does one even start thinking about making a game? So at its core, games are a bunch of ones and zeros, but that's not helpful. The way that Unity structures structures itself is this idea of an object-component relationship, and this is very crucial to how the Unity editor works. On the high level, the idea is that games are full of these objects, and objects are made up of these components. So, for example, we have this ship object, right? Possible components for this ship are transform, which contains its position, rotation, and scale on the screen. It has a physics body, which gives it physics properties such as mass and gravity and velocity and etc. and other things of the like. And then you have a sprite image, which is the actual picture of the ship you see on the screen. And then finally, you have any other scripts that you write. That may be a custom script, move around, maybe to shoot, and maybe another script to explode and die on impact. The sky's the limit with custom scripts. So now, scenes are full of these objects. So we have a ship here. So in terms of objects we have here on the screen, you have your ship, you have the enemies, you have this wavy thing. Even the stars in the background and the UI are also objects. They each have their own set of components that do their own set of things and make the objects behave differently. Right. And finally, on the highest level, games are full of scenes. So obviously you have your title scene, your level scene, and your high score scene that each have their own respective game objects that have their own respective components. So yeah, maybe it seems a little bit straightforward, but it's important to establish this kind of concept of the object-component relationship because it'll be very crucial when we start hopping into the editor. So, without further ado, let's open up Unity. So, if you opened up Unity for the first time, you should see something akin to this. You probably don't have all of this stuff in the middle. This is kind of like this is something I put together earlier. But this is what your screen should look like for the most part. So as you can see, there's all these panels and buttons and doohickeys, oh my. But don't worry, as we go through the tutorial, I'll explain what each panel does one by one. Before I do that though, let's actually show off the game that we're going to be making today. So the game that we settled on is we're going to do like an endless runner. So as you can see, you have a little blue dude that moves along the screen, and you have these obstacles that will move from left to right, and hopefully, and then they loop back. And there's some background objects. We may get to those today, but those aren't too complicated. And then if I fall off, if I go off the edge, I lose. There's no way for me to come back because I actually fall off the screen. Kind of a cheap way to do it, but hey, it works. Okay, so let me open up a new scene. So if you open up the editor, you should see something akin to this. The first thing we're going to do is we're going to hit File, Save. And we're going to save this. You're basically saving the scene. I'm just going to call it tutorial. This is a step that I always forget, and sometimes it comes back to bite me in the butt. So make sure you save before you get started. And essentially what it's doing is you'll save your scene, which I'll explain in a little bit. I'm going to get rid of these scripts because that's what we're going to put together. Okay. So the first panel we're going to be talking about is the projects panel, right down here. So this is where you're going to be putting all your assets for your game. This is where all your scripts, your, say, 2D art, your 3D models, your sounds, your scenes are all going to be here and accessible for you. So the first thing we're going to do is actually make an asset. To do that, you can right-click here in the panel, go up to this thing that says Create. You can see all the different things that you can kind of create by default in Unity. I don't know what all of them do. So go to this one that says Sprites though, and you get a bunch of shapes. I'm going to click on Square. And what this does is it makes a square asset for us. So to go over it one more time, just to make sure everyone's got the gist of it, right-click, Create, Sprites, Square. The second thing I'm going to do is actually I'm going to import an asset from outside of Unity, so I just have, let's say, an image that isn't just a plain square. To do that, you go right-click again, Import Asset. You get brought up to this File Explorer. If I go to Desktop, I have this little image of a dude. And as you can see, that image is now also in the Asset Manager, or the Assets folder. This is the same for if you have any external 3D models or sounds, or even scripts you want to import. That's how you want to go about it. Yeah, so you can even, one thing you can add is you can even create folders here for organization. But I'm lazy, so screw organization.
Don't listen to Jose, organize your stuff.
Yeah, what he
Don't
said.
get messy very quickly.
It's true. Okay, so the next panel I'm going to be talking about is this big gray one over here. This is called your scene view, and where you're going to be doing most of your level editing. So some quick navigation. If you middle click on your mouse, you'll be able to scroll around, you'll be able to move around. If you scroll, you'll be able to zoom in and out. If you're really curious, you can actually hit this like 2D button and it goes into like 3D space. And if you're familiar with like Maya controls, you can actually just, they work almost the same. But we're going to stick to 2D because 3D is scary and complicated and 2D is nice. Okay, so to move assets from the, to get assets into our scene, all you have to do is go to your projects folder, drag them into the scene view, and then drop. So now you can see we have our square. I'm going to move my little dude. He's very large. And yeah, so we have our two guys. You can actually manipulate the size and scale of these objects by using these tools up here. So you have your position tool, which lets you move the position of it. You have your rotation tool, lets you spin things. And then you have your scale tool, which lets you resize. So actually I'm going to like resize my dude because he's very, very large. Like that. And another tool you have is I guess this bounding box tool. It kind of lets you do all of them at once. It's just another way to manipulate objects in Unity. Okay. So yeah, that's most of the scene view. Next, we're going to be talking about this left panel over here called your hierarchy. So this is basically a list of all of the objects in your current scene. So as you can see right now, I'm in the tutorial scene that I established earlier. That star means that I need to save, so you can hit Control S and that fixes it. And we have 3 objects. We have a main camera, which is this thing in the middle. And then we have our 2 objects that we just created. You can actually rename objects in here. Double click? No, it's I usually use F2, but I'm gonna just rename him Dude because those numbers were confusing.
Dude?
Dude. Yes, Dude.
Oh, okay.
Yeah.
Flag?
So yeah, so that is how the hierarchy works. Quick aside, if you want to, you can parent objects in the hierarchy by clicking and dragging over. And all parenting does is that whenever I move my square, the dude moves relative to my square, which is just a nice little thing to know. I'm not going to get too much into it. Okay. The last panel I'm going to be talking about here is the inspector. The inspector is how you see all of the components that are attached to the objects. I told you that thing would come up sooner or later. So right now, as you can see, I clicked on my dude. He has 2 components attached to him. He has a transform and a sprite render. And the transform, again, is the position, rotation, and scale information. And the sprite render is just the sprite image attached, which you can see if I click on here is my sprite guy, the image that I had selected earlier. Similarly, the square has a transform and a sprite render. Some of its information is different, but it's the same components. And then most interestingly, all a camera is a game object with a camera component attached to it. So like I mentioned before, almost everything in Unity is either game objects or components. Some of the nice things about the inspector is that they actually live updates. So as I move things around in the scene, you can kind of see it's changing up in the inspector itself, the position. And I can even manipulate values themselves from the inspector. So I can just kind of do this. Which is handy. Okay, so before I move on, does anybody have any questions or are stuck anywhere? Like I said, we have a ton of officers here who are out here to help if any of you have gotten stuck. Yeah?
That's those 2 arrows like that.
Oh, so this is the, I hit this up here in the position tool. And so you have position, which gives those 2 arrows. You have this rotation tool, which gives this nice looking circle. And then you have this other one that gives very sad arrows.
And you can, instead of scaling it diagonally by touching the middle, you can scale it in one way by just holding on to, yeah. That's what those arrows are for.
Now he's a thin boy.
Yeah. It's for manipulating strand to one axis.
Yeah.
Curious, the keyboard shortcuts are just Q, W, E, R, Y in the same order as the top row.
Yeah. Any other quick questions before we move on to physics and components? Cool. Okay, so actually one thing I almost forgot was how to actually play your game. So if you hit this play button up here, it'll take a little bit, but it'll actually run your game. This is what the game looks like to your players. As you can see, nothing is happening because we haven't told anything to happen, right? So let's go ahead and change that. The first thing we're going to do is make yes?
Do we need to have something for dude, like stand in for dude, since we don't have a picture guy? Do we need to make a square or something like that? Like another thing?
Yeah, you might want to make a sprite to represent what your player would be.
Okay.
Yeah.
Use a circle or triangle or any of the other sprites, or if you have your own image you want to use.
Yeah, something I like to do also, if I'm too lazy to actually draw art assets, is that you can actually change the color in the sprite renderer. So like I can change the color of the sprite here, and so it's like, oh, this is my player. And yeah, that's usually when I'm demoing things out, that's where I go ahead and start. Oh yeah, it was 0. Okay, so we're gonna add physics to our object. Luckily, all physics is, at least in Unity, is another component. So if we click on our, make sure we click on our dude in the hierarchy, make sure we have him in the inspector, and we click on this button called Add Component. And what you see, if I do this, you can see like all the component settings that you can add. But if you type up in the text box up here, you go rigid body 2D, click that, you get this component. So the rigid body component is Unity's like default physics system. You can see it has all these settings you can toggle. We're probably only going to touch 1 or 2 of them here, but it's something I recommend exploring as you go along. And so now if you hit play, our dude is going to fall down to the floor. So the reason he fell to the floor is because we haven't actually given him a collider. And so the collider is going to tell it, the collider is going to stop, if it hits something, it's going to stop it from moving. The easy way to do that is if you go into your add components, type in box collider 2D, click that. You can see we have this new box collider. Also, forgot to mention, you can use this arrow to turn on and off these, to hide these components. I don't know why they hide by default. That's kind of weird. But just to kind of explore the box collider a little bit, you can see there's now kind of like a thin green outline around my character. And if you hit the edit collider, you can actually see it a little bit more abruptly. You can like move it around to kind of affect the shape of your collider. But by default, Unity shapes it to your object, which is pretty handy. So now if we hit play, he still falls to the floor. Yay! And the reason for that is because we need to actually also attach a box collider to the floor. So to do that, I'm also going to name this floor just for organizational purposes. But to do that, all you need to do is click on Add Component. Because you can see it already has the box collider 2D option open. And click on that. And it automatically sizes the box collider to our floor here, which is nice. So now if we hit play, we fall down and we don't fall through the floor. Yes. Awesome. Yeah, I know I kind of went through a lot of stuff there, and also feel free to raise your hand and ask questions if I'm ever going too fast. But how's everybody doing so far? Is anybody behind, confused right now, or have any questions or anything? So feel free to speak up. Okay. So because the next part we're going to be doing is scripting, which is where it gets a little bit complicated. So if you are behind now, this is the point where you really want to catch up. So I guess one more round for people just to see if everybody's on the same page. Don't be shy. All right. Okay. So.
Good question.
Oh, yes?
My platform and my dude seem to fall down.
Oh, both your platform and your dude? Oh, that's because he's going to help you take a look at it. But my guess is that you added a rigid body component to your floor as well.
So we added a rigid body for box.
Yes. Yeah, because now you've given your floor gravity. So, and I guess if anybody else has run into this problem, I'm gonna just simulate it here real quick, right? As you can see, our floor is gonna fall down, which is not what we want. To fix that, click on the object, go to its inspector. You can right-click on the component, and then you have this button here that says Remove Component. So if you ever want to remove components in general, that's the way you want to go. You can go about that. Okay. Any more questions?
How do you remove it?
Huh? Oh yeah. So you right-click on the component, like up here, and you can remove component. But I don't want to do that because I need that. It's important.
And if any of you guys have a question that's particular to just like something that's screwing up on your system, call one of us over and we'll take it off for you. Okay.
So any other questions? Oh yeah. Oh, you want it? Okay. So to do a quick, I might have gone over it a little bit fast, but what rigid body does is it applies physics to your object. So like what it's doing to my guy is it's giving it it's giving it a mass, it's giving it gravity, which is what's most important, and it's giving it some other properties like a velocity as well. So for right now, the best way to think about it is the rigid body is what's causing our object to fall down and obey gravity. You can actually even toggle, you have this setting here called gravity scale. So for example, I'm getting a little bit ahead of myself here, but if I wanted to like increase how strong gravity is, I can hit 3. And you can see he moves, that's not too much faster. Let's make it like 10. So it moves, you can see it moves a little bit faster. Go 100, what happens in 100? Yeah. Yeah, I'll talk about also being able to toggle these settings in a little bit. Okay. So without further ado, let's move on to the next section, which gets where we code a little bit. So what we're going to be doing next is making our player, giving our player the ability to move left and right and jump. In order to do this, we're going to be making a C# script. So to do that, what you want to do is you want to go to your assets folder here again. You want to right click, go to create, and then you have an option here for C# scripts. And what you can see here, it has this new kind of file. I'm going to name it dude move because I'm good at naming things. Or just name it dude. Where's my dude? Yeah. I see. Yeah. But yeah, so the script here, as you can see, it's C#.
Jose, I have a question.
Oh, yes?
Would we want to call it dude if we already have a component called dude? Like, is that confusing at all?
For components, yes.
For an asset, I guess.
For an asset, yes. But for like I guess for a component, like if you name your thing like rigid body 2D, then you'll have a problem and it'll get confusing. But if you have like right now we have an asset called dude, it shouldn't be too much of a problem.
Could I call it something else if I wanted to?
Yeah.
Okay.
There's no.
have to call it dude.
It's your required. Actually, all my games have a dude.
Sorry, dude code.
Dude code.
What code? Dude code?
Dude code.
That's a secret. That's a pro strat. So now, if we want to open up, first before we open it up, we should attach it to our player. To attach the script to our player, there's a number of ways we can do this. You can click and drag it onto your object you want to in the hierarchy, and you can see that now dude is like a component in the inspector. I'm going to get rid of that here. Or the other way you can do it is you can actually type it in the add component tool. You can see that dude is now a component that you can add to objects. Before I move on, I know I went over that a little bit fast, but does anybody have any questions? Okay. Oh, yes?
So you switched to something else, right? Because you named your sprite floor, and now your other asset for dude is called dude still?
Yeah.
Up there? Okay.
So yeah, we have dude, which is this object here,
Okay.
right? And then if I click on floor, in the hierarchy, it selects it in my scene and opens it up in the inspector.
So when you put your C# code on dude, is it going to be dude underneath dude again?
Yeah, in a
Okay.
sense. Like it's the object is named as dude, and then he has an opponent attached named to dude, which I can. Oh, I have two dudes. Which may get confusing.
But it's not crucial to like the writing of it. Though,
No,
right?
no. All the names of these game objects they're kind of more for your benefit. It doesn't really affect the actual code. And Unity does a pretty good job about dividing up like the namespaces for this stuff. So let's go ahead to actually open up the script and start writing. You'll just double click, and it'll take a little bit to load. Mine's a little bit faster because I do this more often. But while it's loading, let me kind of give you the a basic rundown on how Unity works. So Unity can understand Unity uses two types of languages, JavaScript and C#, and you can choose either one. I recommend using C# though because JavaScript has its own problems. But for those of you who are, oh, Shine?
JavaScript is actually getting completely phased out in the future.
Really?
So do not use JavaScript if you can help.
Fantastic.
Wait, didn't they get rid of it as of
Okay, that's actually.
No, that was mono. That was mono.
I see.
It's getting very fast.
JavaScript has a lot of problems. Learn C#. For those of you who don't know C# though, no worries. It's actually very, very similar to Java. So if you've taken 142 here, you'll actually see a lot of everything will seem very familiar. And for those of you who haven't, you have a question?
Yeah, can I don't use the Visual Studio?
Huh?
Can I use my own ID rather than Visual Studio?
Yeah, you can. It takes a little bit to get set up. I know there are some people here who do use like they use Visual Studio Code. I think somebody actually set up like Notepad++ at one point. But yeah, you don't have to stick the IDE. You just have to jump through some. Oh, not Microsoft Word. Please no. What was I saying? C# is similar to Java. And for those of you who've never coded before, we're not going to write too many lines. I think I counted it's like 15. So it's not going to be too bad, and I'm going to explain it along the way. So hopefully all of your IDEs I've opened, and you should see something that looks akin to this. I'll explain what these do in a little bit, but the first thing we're going to do before we do that is we're going to make a couple of variables. These are essentially properties that you can use to modify your script. So the first thing, for example, we're going to do is we're going to make a speed variable that controls how fast our guy is going to move. So you do that by saying public float speed. All a float is like a decimal number, which is handy. I'm going to make another float. I'm going to call it jump height, which tells how high our dude is going to jump.
Can everyone in the back read this?
Hopefully. Okay. I probably should have switched it to light mode at some point. Oh yeah, I can make it bigger. There we go. And the last the last thing I'm going to write is might be a little bit more confusing. So I'm going to do private rigid body 2D. I'm going to call it rigid. And I'll get into what that actually is in a little bit. So now I'm going to move on to what these are here. These are called functions. These are where you're going to be writing the bulk of your code, or writing the instructions for your character, for your game objects. The first one here, start, says that everything that you write in here is going to be called on the first frame that your object's alive. So typically, it's going to be the first frame that the game starts, and it's never going to run again. And then update is going to run once per frame. So this is where we're going to be actually like putting in our movement to work across every frame. So in start, what I'm going to write here is I'm going to say rigid equals get components rigid body 2D. Okay. So now let me actually explain what this is doing. For those of you who were paying attention earlier, this should actually look pretty familiar because it's actually referring to the rigid body 2D that we applied to our dude earlier. So the really cool thing about Unity is any component that you attach to your object, you can access in your code and modify. So in this case, I'm grabbing this. What this is doing is it's grabbing a reference to the rigid body 2D that I attached to my player and just naming it rigid. And so now, if I go to update, I say rigid.velocity equals new vector2, and all a vector2 is a xy coordinate. And give it, say, speed, and in this case, I'm going to give it rigid.velocity.y, which all it's saying is I want to move to the right by speed, and I want to keep its y velocity whatever it currently is. And make sure and then you hit save, which is Control F, or you can go up to File and Save All. I thought there's a regular save option. Oh, you can hit this button right here, this floppy disk.
I can save it.
Yeah. So Control S, you'll see that there was a star up there. Now it's gone. And then you go back to your editor, and it'll take a little bit to load. If you hit play, You guys gonna move over to the right. CS. Yeah?
Can you go back to C#?
Yeah, yeah.
Can you go to the
Oh, the variables?
Yeah, the variables.
Yeah.
There you go.
Oh, yeah?
So, if there's like a bunch of objects and update is it's called once per frame, does that mean like update is called for every single object once per frame?
Update will be called for every script that has update on every object. And yeah, that could, like, if you have a lot, it'll like lead to slowdown, but I've never ever hit a point where it actually has. You have all right.
So when we write that and then save that and then go back to Unity, do we take the C# and drop it on dude?
So that's what we had done earlier. So as you can see, we already have it attached. But if you don't have the script attached to the player, so like it's not here, what you can do is you can go to make sure you have your dude selected. You can go to add component, and then type in dude, and the script will be there.
Okay.
And I'd also be careful because you can also add like 2 of the same script. So I think this will make it so it moves like twice as fast. Okay, never mind. I guess not. But yeah, make sure that your dude is attached. Your script is attached to your object here. And yeah. Does anybody have any questions or is still trying to catch up? Yeah, I'll give some time to for everybody to get caught up before I move on to the next section, which is actually pretty straightforward. We actually did the bulk of the work at this point as well, so it shouldn't be too much harder. It won't be too much more complicated.
I opened the JavaScript file anywhere and saved it. It was amazing. Also, don't do it.
We haven't put input yet. So right now it's just going to move right continuously. We haven't told it right.
Is this so if I rename this would extend oh yeah, it does say good
I see you're getting that.
This rigid load 2D should be very
Yes, that's the way to go. It's like I've done these and I know this because I've done it so many times. Yeah?
There's vector 2 object, right? And I found there's even a vector 4.
Yes.
So how do we use the fourth dimension in our game?
So the only time have you color? I think there's a color for that. Oh yeah, alpha check.
Computation.
Oh yeah, that's true. Yeah, no. So yeah, there's on top of vector 2, there's a vector 3 that has an x, y, and z, and a vector 4, which was it x, y, z, and w. I've never used vector 4 in my life, but if you get more complex, like if you want to talk about quaternion rotation or some other stuff, talk to Suki about that. He knows that better than I do. Okay, so let's go ahead and get moving along here. Now that we have, we have velocity moving, let's make it so that it reacts to our input. So in order to do that, we're just going to write an if statement. So this is what this is going to say is if input dot get key. Going to give it a key code right arrow, and then I'm going to put brackets around this just because it's good style. And so essentially what this is saying is that whenever we hold down the right arrow key, we're going to have our player move over to the right. Similarly, I'm actually just going to copy and paste this. Else, if input.getKey key code left arrow, we're going to set our rigid body's velocity to negative speed. So it's going to move in the other direction. And finally, just to kind of fix a bug that'll come up later, we're going to write an else statement saying that if we're not pressing the right or left arrow keys, we're going to set speed to 0. So he's not going to move in any direction. There are other ways you can do this that have some other advantages, but this one's just kind of the easiest to kind of wrap your head around. Again, just to go over, what this is saying is that whenever I move the right arrow key, I'm going to move to the right. Whenever I move to the left, hit the left arrow key, I move to the left. Else, I'm not moving at all. Don't worry if you haven't gotten all this typed out, I'll come back to it. But I just want to hop into the editor and explore here what's going on a little bit. So make sure if you've saved your script and everything is working, if you move right and left, you can actually see that your dude is moving right and left. Yeah. Okay, I'm going to go back here just so you guys can see what the code looks like. Okay. Does anybody, any questions? All right. Before we teach our player how to jump, I want to point out one more nifty thing about Unity. So if you go back into your expector, you make sure you click your dude, and you look at your dude script, you'll see that you have a couple more options than you did before. And these values here are actually the variables that we wrote out earlier. So the nice thing about Unity is that any variable that you mark with this public, this mark as public here, is going to be available in the editor for you to change. So if I wanted to, for example, if I wanted to change the speed from 5 to 10, I can do that right here in the editor without hopping back into my code. You can see that he's moving left to right faster. And the nice thing is, even when you're in play mode, you can change these values. So if I want to make him move 20 speed, now he's moving super, super fast. Or I can put it back to 5 and he's moving pretty slow. The one thing to note about changing values in the editor is that whenever you go out of play mode, it'll actually undo any of the changes you made, which is a little bit of a hassle. So most of the time, the best thing is to either just kind of memorize the values that you've changed to, or something that's a little bit more useful is that while you're in play mode, say I want to change this to 10, you can right-click on the component in the inspector, say copy components, and then when you're out of play mode, you can say paste component as new. Oh, well, no, not that one. Just kidding. You can say paste component values. So yeah, that one's just a little bit extra, but it's something that's nice to know. Okay. So the next thing we're going to do is we're going to teach our player how to jump. In order to do that, we're actually going to write something that looks very similar to this previous code. I'm going to say if input dot get key down, which is saying that whenever on the first time we press the button, say key code dot up arrow, we're going to say a rigid dot velocity equal to new vector 2, and I'm going to say my x value to rigid dot velocity dot x, and my y value to the jump height variable that I created earlier. Okay, so now if you go back into your play mode, you should see that our dude jumps now. He got some hops. Obviously, he doesn't jump very high, so we can actually mess around with these values to get it to feel right. So like, obviously, if I set it to 15, you can see that he jumps a little bit higher. If I set it to, say, like 50, high values are fun. There he goes. There he goes. He's back. So I'm going to set it back to 15. Also, when I'm doing this, like also playing around with the gravity scale to try to get a nice sense of, to mess around with things and get a nice sense of force downward. But yeah, all that is at this point is just like toggling values, right? And from here, it's just a matter of like playing around, seeing what works, and you don't really have to go back into the script unless you want to tweak something more precise, which is nice.
When you toggle the when you're testing it, does it save it or?
It does. So when you're in plane mode, it doesn't. And so typically what you have to do is remember the values and change them back when you're in editor mode. Or as a kind of a shortcut, when you're in play mode, you can right click on the object, hit this like copy component, and then when you're in editor mode, you can right click and then paste component values, and that like again like you're copying the values that you changed and then pasting it in back.
So it
into
copies
the object.
everything.
It copies the single component. So like
let's say you change the speed in the test.
Yeah, so let's actually, you can go ahead and
Will
do
it
that.
only copy the speed? Or
It
if
will-
you change both the speed and the jump height, will it copy both of them?
It will copy both the speed and the jump height. However, if you like change this, for example, the speed, the jump height, and the gravity scale, like save this, it'll only save this save the speed and height information.
So if you wanted to change two different components, you have to do it again.
Yeah. So I don't think they have a solution for that. They might have it now, or maybe one day in the future. But as far as I know, you have to go component by component. But yeah.
Can I see the
I'll go back.
Any
Yeah.
questions?
I'll leave this up here, so anybody who's still typing can get caught up.
Looks like completely lost.
Yeah. Out of curiosity, is there anybody who's like completely
There's
lost
no
right
shame
now?
in that.
Yeah.
My first unit tutorial did a completely different projects. It's too hard. No?
Yeah.
So I guess get key down only inputs like one instance.
Yeah. So get key down is like on the initial button press, it activates the jump, as opposed to get key, which is like continuous. So as long as I hold down, it like runs that code. Oh yeah. So the problem that I'll address a little bit later is that if you keep pressing jump, he will jump infinitely. There's a solution for that. I'll get into a little bit later. It's a slightly more complex, but which is why I'm going to talk about it at the end. But if you're making like Flappy Bird, there you go, right? It's not a bug. It's a feature. I swear. Is there anybody still copying down the code though? All right, cool. So yeah, like I was mentioning earlier, you can go back, you can move around, you can jump infinitely. I still don't like that jump. It's way too small. It's going to become a problem later. Say like 20. But yeah. So the next thing we're going to do is we're going to start adding some obstacles. So to do that, it's pretty simple. I'm actually going to cheat a little bit. So in your scene view, you can actually copy and paste objects. So if I hit Control C on the floor, Control V, I have like a second version of the floor called Floor 1. I'm going to change its size a little bit. I'm going to change its size a little bit. I'm going to make it so that you change its color. You can do that by going into your sprite render and changing the color. And so now, if I, now I have another object that I can collide with. Oh yeah, that's another neat thing. Thanks to the rigid body system, I can like rotate. That's something, again, I can show you how to fix later. Actually, it's really easy. If you really want to fix it, you can hit this reuse rotation, and now he's frozen. He doesn't do that anymore. But I find this more fun, so it's goofy.
You can do what I did, turn that into a game. I have a game called Spinny Cube. That's the premise. Except the controls flip with the cube.
Cube Town? Cube Town.
Oh no.
But yeah. Okay, so yeah, now you have an object here. What we're gonna cheat a little bit. So we're gonna do an endless runner, and usually what it looks like is your players like continuously moving to the left while objects are standing still. For this game, you're gonna be standing still, and objects are gonna be moving towards you. Again, not how things work in the real world, but the real world sucks. Okay, maybe not. The real world is great, guys. Too real. So what we're gonna do is we're gonna make another script. Don't worry, it's gonna be like 4 lines of code. And the way you can do that again to make a new script, you can right-click, create, go to C# script, and then just name it. I named it like object. But another way you can do that is you can create a script. Is you can go into add component, type the name that you want to name your script. I'm going to name this like object, and then you can click on this button that says new script, and then you take into this window that says you can give it a name, and then I'm going to say create and add. And as you can see, not only did it add that object to my project folder already, but it also added that object to that component to the object itself. Probably shouldn't have named it objects because you have other objects in the screen. I'm really bad at naming things. So now that you have that, if you double click on object on the script, or you can double click on the component itself in this little like box here, it'll open it up in the menu. And hopefully if you kept your IDE open, it should open up pretty quick. So what I'm actually going to do is I'm going to get rid of this because we don't need it. I'm going to make another variable speed just to kind of tell how fast we want our object to move. And then for here, I'm going to say in update, I'm going to write transform, lowercase transform, dot translate. I'm going to say vector, in this case, vector3 dot left directions times speed times I'm going to actually do this because if we don't have that, it's actually going to move incredibly fast on the screen. So essentially, this is a slightly different way of doing positional movement. I'm saying every frame I want to translate my object to the left by speed times 0.01. Is it pixels? I always forget if it's pixels in Unity. Let's pretend that it's pixels. So it's going to be moving to the left at that speed. The other thing I'm going to do real quick, I'm going to make this public, another float. I'm going to call this like bound. I think I'm going to set this to, for now, like 5. I would say like 15, 13. And what I'm going to do here is I'm going to I'll write this out and explain what it's going to do. So if transform dot position dot x is less than bound dot bound. I'm silly. Negative bound. We'll set the transform dot position. Just transform dot translate just to keep it. Vector3 dot right times bound times 2. So what this is going to do, I'll hop back in the editor just to kind of do a quick demonstration. So what this is going to do is that our object is going to move along. It's going to get past a certain x position, as you can see up here. It's going to, like I said, it's like 13. And when it hits that point, it's actually going to respawn the object on the other side. So it looks like he's continuously moving. So yeah, I'm going to hop back to the code so you guys can copy it down. See, while you do that, I'm going to talk about a little bit more complexities about coding while we have the time. So whenever you have like a component, like the rigid body, or in this case, like transform, if you want to access its information, if you want to access some of its attributes, you can hit this dot. Sometimes, depending on the IDE, sometimes you get this nice drop down. But like, for example, I wanted to access the transform, the position information. I hit transform position. I can do like transform rotation, scale. And that's just how you access any information in a component using this dot notation. Something that's nice to know. Does anybody have any questions or is following line? Yeah?
Did you definitely with vector 2?
Yes. Yeah, yeah. If I wanted to, I could do vector 2 as well. Yeah, the only difference is that, it's 3 versus 2. Sometimes it's picky if I do like transform dot position equals, I guess if I do like transform position plus say new vector 2, or to say like vector 2 0, vector 2 0, it's going to yell at me. Oh, it's going to yell at me anyways because it's not connected to anything. Yeah. It's true. I don't think it messes with anything. It's so fun. Yeah, yeah. But yeah, it'll yell at me here because it's like a vector 2 adding to a vector 3 and it doesn't know how to deal with that. Let's see. But yeah, is anybody have any? Okay, is everybody caught up or need to? Oh, you gotta. Oh yeah, yeah. Seems like everything. Okay, anybody, another call? Anybody still typing out the code, or are we all good? Or are you still looking? Okay, so again, if we go back to our player, as you can see, if we're moving around, we have our guy falls over, and we have an object. So at least for the basics, that's all of the code we're actually going to write. Thank you. So that's all the code we're going to actually write. From here, you can actually start just fleshing out your game some more, right? So let's say if I wanted to have make it faster, I can do that. If I want to make like some more obstacles, I can kind of stretch it out, make it longer. Oh, that's way too high. I'm gonna lose. Start making levels. Oh, that's right. I can infinite jump, can I? I'm not supposed to, but I can. And I'm gonna actually just change this value here because it's way past 13. Make it like 30. And so now, if I hit play, do this. Yee! It's a game. We have a game, guys. Yay! So there's a couple more things I want to talk about. But the nice thing is, like, we only wrote like 15 lines of code, and we already have something that we can start actually building things out with. So, for example, going back to that earlier example that I had made, right? This game looks slightly more better. It's got its jump feels a little bit better. It's got a lot more shapes and objects. Even got some background stuff. I didn't have to write any more code than I did just now, though. For example, even like those background objects, all those are just objects that I attached that obstacle script to. In this case, I call it obstacle movement because I was writing it earlier, and I just made it so it doesn't collide with anything. And by messing with the speed and some of the speed in the settings, it looks like it's moving in parallels. So, like just from the little that we've done, you can already start making engaging games.
Hey Jose.
Yeah.
How did you attach the object script, or what exactly is that? The object script.
So like the object script is like the one that we wrote earlier.
Okay.
So.
So it's another C# thing.
Yeah. Well, so the object movement script that I had there is the same thing as like the object script that I wrote. It's just that I wrote it earlier. I was prepping for the tutorial. And then you'd attach that script the same way that you attach the dude component, the dude or the objects one that we wrote this time around.
That's it. You'd have to write that one too, right?
Yeah. But it's essentially the same code that I wrote for this one. Which is prefab. Oh, because you know why? It's because I'm on the wrong thing. Let's see. Yeah. So the last thing I'm going to talk about before we take a small break is this idea of prefabs or prefabricated objects. So let's pretend, right? I made this level, but I decided to myself, hey, I want my objects to move a little bit faster. Right. So the way I do is I go into one object, I'd set its speed to 15, I'd set its speed to 20, and then I'd have to go into another object and then also set its speed to 20. And even if I want to move it a little bit faster, I can select all the floor objects and the hierarchy and change its speed to 20. But that's annoying and a hassle, and I want to be able to do it on the fly. And the way we do that in Unity is through prefabs. So I'm actually going to get rid of the rest of these objects. I'm going to rename this to, I don't want to call it object. I'm going to call it block. There we go. That's a word that makes sense. So to make a prefabricated object, what you do is you click on it in the hierarchy, you drag it down into your project folder, and now as you can see, we have a prefab. We have this kind of thing here called a prefab. So again, to kind of review, click on the object, drag it into the project folder, and bam, prefab. Now, if I wanted to add more blocks, all I need to do is drag them in, and now we have carbon copies of that object. And you can do this across multiple scenes across your game, which is nice. Now, to address that problem that I had mentioned earlier, let's say I want to change the speed of my object. I can go down here to the speed variable. I'm going to set it to, let's say, 30. And as you can see now, it's highlighted in blue and bold. If I right-click, I can hit Apply Prefab. And now all objects, all those prefab objects, now have the speed of 30. And as you can see, also, prefabricated objects turn blue in the hierarchy. I forgot to mention that earlier. So yeah, now I can mass change objects without having to go into them one by one. To give another quick example, let's say I want to change the color of my object. I can click on color, I can change this thing, I can change its size, I can change its color, excuse me. And then I can again right-click the color setting and hit Apply to Prefab, and now all my objects are orange. Now, changes won't carry over unless you apply them, so changing the size and shape of these objects won't affect the original object by default unless I tell it to, which is handy. And these objects, if I change one, these objects will also stay the same because they know that they've been changed. So again, if I hit play, it's really fast. Okay. Games. Yeah, it was crazy. But yeah, so you've gotten this far. Congratulations, you've made your own game. There's a lose condition, which is what I classify as a completed game. There may not be a win condition, but there you go. So yeah, you've made your endless runner. Obviously, there's a lot more that you can do with this. I'm actually, in a little bit, I'm going to actually talk about how to fix some of the bugs that I had mentioned earlier, such as the infinite jumping. But for now, we're going to take a 10-minute break to let you guys catch your breath and ask any questions that you have. So yeah. Yes. So the way you do that, I'm going to do the floor this time around. You can click and hold on the hierarchy and drag it into the project.
It's not even.
Yeah. So if I wanted to put it back right, I can drag it. See, I have my.
Oh my god.
I can drag in carbon copies.
This game.
And then if I hit play,
software.
yeah.
Oh my god. Oh no. Now there are more of an army of. It's an army of Jose. Jose.
And then there was
Oh no.
So yeah, James. Yeah. Yeah, feel free during this time to get to ask questions and also like play around with the settings because obviously you can tweak around like the jump height and speed and the speed of the blocks and such to get what you need. Yeah.
These are all buttons. It's not a game. Apparently, it's according to say, yeah, it's very hard. It's a timer running. It doesn't disappoint. So you want to guess how yeah, you're going for high school.
I have the dog.
As you can see, I realized the dongle when I wrote the object. A, we have that notion of going over the objects, so that was kind of dumb. And B, there was obviously objects are objects. So I didn't really think that through off the top of my head. But yeah, that's
Here's my dog. My dog.
Alright, yeah. Okay, quick thing, we gotta head out.
Okay, Shine, are you gonna show your game too?
If you want to download it, I'll put it on the Discord.
Okay, quick,
This is not HDMI, right? This is not HDMI.
Oh, what? Oh, my bad. Sorry. Well, the other one doesn't fit on the
Oh, wait, actually I can't even show my game.
okay, never mind.
This is on this.
Thanks, my dog.
Hey Jose, you want to show
Yeah.
the game?
Oh yeah, I'll see your game.
Wait, is it just close? Yes!
Oh my god.
Right?
Especially on a fucking trackpad.
There is an end win condition. There's no lose condition. Because I haven't made a game, Jose.
I'm sorry. Make a game. Come on. What are you doing? I know, like
You're out of time. You have to submit it. Mostly. Oh, dang. What the heck? That's so good.
what is this?
This is HTML and JavaScript.
Oh my goodness.
Here, wait, here's mine.
Show me the game. Let me play your game. Right now. Nice game. Arrow keys.
And then the speed at which it gets faster and faster.
Okay, one more time.
That's a lot.
I know it's a little bit fast. Quite able to hit that sweet spot where it's like fast enough, it's going up for everybody to fight it. Yeah.
Alright, so Jose, you want to check my code out?
Oh, yeah.
This is for.
Inside
Oh, I know what's
today, do you have to create a so these buttons are okay. Literally just each button. So if you look at the HTML, it's missing. When you create sometimes you don't see that. That happens.
Does anyone here not have a Discord?
There's a are you just trying to click on
Regarding that, I'll do
I've coded them actually. Won't that like make it run big each process?
Something on Discord. Can you change this? Thanks for coming.
No, instead of clicking, make it small.
Can you get the thing to compile without changing the class name?
I did. I didn't have too many problems. Yeah.
Yeah, I have a meeting at 3.
All right. Yeah. Okay, so feel free to pick. I'm going to talk about how to fix some of those like trickier bugs real quick. Oh, what?
Okay, so it's just.
Oh, really? Okay. That's fine. Then everybody who's here is going to get like the secret lowdown on how you make good games. Yeah. So there are going to be 3 bugs I'm going to address, or 3 things I'm going to address. The first thing is going to be the Spinny Cube thing, if that's something you want to fix. The second thing is going to be getting stuck on the wall. So what will happen here is like, if I hold to the right, I'm actually going to like get stuck, which is kind of annoying. And the third thing I'm going to fix is the infinite jump. Maybe let's say I don't want to make fun.
It makes your game hyper-realistic.
It's true. So the first 2 are actually pretty straightforward. To fix the rotation, you want to go to your rigid body and you want to click on freeze rotation. And so now he doesn't spin, which is a good thing or a bad thing. The second thing I'm going to address is the moving to the getting stuck on objects. And so in order to do that, the first thing you want to do is you want to make a thing called a physics material. Do that, you go to right click, go to create, and then you want to make a physics material 2D. And I'm just going to name this, just keep it the same thing for now. And then so you click on it and you'll see that it pops up in the inspector menu on the right here. Change friction from 0.4 to 0. Then click on your player and drag this. Actually, click on your player and then drag this into this material slot in rigid body 2D. So you have a new physics material in your rigid body 2D. And now you don't get stuck on the wall anymore, which is nice. Okay. All right. Does anybody have any questions about those two things? Yes. So you want to. It's not that physics materials aren't necessarily actually components. They're like one of the things that aren't. So what you want to do is you right-click, create physics material 2D here, and then when you clicked on it, it has its own inspector settings. Change that to 0, and then attach it to the section in the rigid body. Yeah. All right. Any other questions about those quick fixes? All right. So next thing we're going to do, probably the most complicated thing we're going to do here is we're going to use raycasting to fix the infinite jump. If you don't know what raycasting is, I'll explain it. So we're actually going to go back. We're going to open up our dude script once again. We're going to write a little bit more. First, I'm going to make something called a layer mask, public layer mask. I'll call this ground. And the second thing I'm going to do, I'm going to do some stuff. Raycast. Let's see the raycast hit 2D. Call this hit equals physics 2D dot raycast. And I'll explain what this is doing in a little bit. I'm just going to write it out. Transform dot position vector 2 dot down. I'm going to say its position is 1, and I'm going to set it to ground. And then I'm going to do and hit. So just a kind of a brief summary of what raycasts are. Raycasts are like lasers that you can shoot in a direction, and you use it to tell if that laser hits something, you can grab its information. So what I'm doing here is I have a physics 2D raycast because we're using 2D physics. I set the first parameter here is its origin, so where the laser starts. The second thing here is the direction that it's going to go. In this case, it's going to go down. This value here, 1, says how long our laser is going to reach, and then this ground plane says that any layer that's in this ground layer mask is going to get hit by our laser. And I'll explain how that works in a little bit more detail later. And then what I do here is I append this hit variable here, and so what this says is that if I hit the up arrow key, and I'm hitting something, I want to jump. So it's just something a little bit extra, and then there's a little bit more setup we have to do in the editor. There's a little bit more we have to do. First thing we're going to do, we have to establish what layers are. Layers are just a really nice way that Unity has for you to organize things and identify certain objects. So in this case, I'm going to make a new layer. I'm going to call it floor. And then I'm going to, in my floor object, I'm going to change the layer to floor. In my block objects, I'm going to change their layers to floor and also update it to all prefabs, so all blocks are objects. And then now if I go to my dude, you can see there's that ground layer mask that I have here. Right now it says nothing. And if you click on it, you have a list of all of your layers. I'm going to click on floor. And now if I play, I can't infinitely jump anymore. Whoa. Amazing. Again, I'll go back to the code, but to just briefly go over what you need to do in the editor, you have to go up into your layer. You can either make a new floor layer, which is what I would do, or if you really want to, you can use one of their default ones. Set all of the objects you want to be your floor as that layer. So in this case, all of my kind of objects, other than my dude, are floor. And then set it so that the ground plane is going to check if it collides with any floor layers. Yeah. So yeah, that's all I really had for this tutorial. We have the room for the next 15 minutes, so feel free to hang out, ask any questions, or even play around with the thing that you built today. Yeah, so thanks everybody for coming. I hope to see you all next week. And in terms of announcements, next week we'll be stepping away from tutorials for a little bit, and I'll be doing a talk on rapid prototyping. So look forward to that. Yeah. No. Yeah.
Or Jose.
Yes. Yes.